Hi friends, in this particular video I am giving you a brief idea about the serial port control registers of 8051 microcontroller. So in the previous video I was already explained the various timer or counter registers followed by modes of operation of timer or counter. Whereas here let us see what are the various serial port related control registers present in the 8051 microcontroller. Here. See the topic, we have two registers comes under serial port operation. One is called it as a SCON register, other is called it as a PCON register. Let us see first SCON control register. What is the full name? The SCON is a serial, S is a serial port, CON is nothing but it's a control register. So we can make it like a control or status register. That's why short name is serial port control register, serial port control or status register also we can call here. Okay. Let us see briefly. So what are the various bits present in the SCON register? Here first is RI, then TI, then RB8. Okay, this is nothing but receiver interrupt, transmit related interrupt flag. Similarly, RB8 receiving bit 8, whether we are receiving 8th bit or not. Similarly, whether we are transmitting 8th bit or not, that's why TB8, transmit bit 8. REN, receiver enable. Similarly, SM0, SM1 and SM2. Okay, all three are called as serial port mode control bits. Three bits are there. We'll see detailedly what is the functioning of each one. Let us see first SM0. What is the name here? SM0 is a SCON register 7th bit, because bits are from 0 to 7. That's why SCON register dot 7 is a 7th bit. What is the name? It's a serial port. S is a serial port. M is mode. And it's a one type of control bit. That's why serial port mode control bit of type 0. So serial port mode control bit 0. Okay, so now this bit is set or cleared by software. So with the help of program, we can either set or reset this particular one. With the help of program, we can either set or reset. Next, let us see SM1. What is SM1? It's a serial port mode control bit 1. Previous one is bit 0, now bit 1. So this bit also set or cleared with the help of software, nothing but with the help of program, we can set or reset. Then other is SM2. SM2 is a serial port mode control bit 2. This bit also set or reset with the help of software or program. Then REN. What is REN? It's a receiver enable control bit. Receiver enable. So if this bit is enabled, then only receiver is ready to receive the data from the external serial port device. So receiver enable is also important. Receiver enable control bit. So this bit is again set or cleared with the help of software. Through software only we can enable or disable this particular REN bit. Name is receiver enable control bit. Then TB8 is transmit bit 8. So this bit is set or cleared with the help of hardware. Through hardware connection, we can either set or reset this particular TB8. Then RB8 is receive bit 8. Previous one is transmit bit 8 and receive bit 8. This bit also set or reset with the help of hardware. Then TI. TI is transmit interrupt. Transmit interrupt means here, this is a transmit interrupt flag set by hardware. With the help of hardware connection, we can set. Clear when that interrupt is processed. Whenever this particular transmit interrupt interrupt is processed, then automatically this TI flag is cleared. So when this TI is set with the help of hardware, and when it is cleared, whenever this interrupt related instructions are cleared, automatically TI is reset. TI is reset when that interrupt is completely processed. So next, another important point is based on SM0 and other is RI. What is RI? The receiver interrupt flag. Same receiver interrupt also set with the help of hardware like a TI. RI receiver interrupt also set with the help of hardware and cleared when that interrupt is completely processed. When that interrupt is processed, it will clear automatically. And one more is based on SM0 and SM1 bits. 8051 performs some separate serial port operations. Let us see here. For example, SM0 and SM1 both are 0, 0, then 0, 1, 1, 0, 1, 1. Then based on SM0 and SM1, it further operates into 3 modes: mode 0, mode 1, mode 2, and mode 3. So in mode 0, now operation of serial port is it's a shift register operation. In that baud rate is frequency by 12. For example, our clock frequency is F, our machine frequency is F, then baud rate means the number of bits it can transmit is frequency by 12. That many bits it can transmit if it is 0, 0. If it is 0, 1, it's a 8-bit UART. What is UART? It's a universal asynchronous receiver transmitter. So 8-bit UART operation is possible. In that case, the data rate, transmission rate is variable data rate. If it is 1-0 operation, now it's a 9-bit UART. It's a 9-bit UART. Okay, in that fixed baud rate is fixed, and baud rate is approximately frequency by 32 or frequency by 64 is possible. If it is 1-1, then here also 9-bit UART with variable data rate, variable baud rate. Here baud rate is variable. Like that, whether we are performing 8-bit UART or 9-bit UART decided by SM0 and SM1 bits. Like that, SCON register is very essential for a transmitter as well as receiving of serial port information. Coming to another serial port register, call it as a PCON. Let us see what is PCON. So PCON is a power mode control register. PCON is a power mode control register. Okay, it is also one type of serial port register only. Family of serial port. PCON is a power mode control register. Here, let us see PCON register bits 0 to 7. In that, last bit must be SMOD. SMOD bit, then IDL, then PD, GF0, GF1, and 4, 5, 6 are reserved, future reserved bits. So coming to SMOD first. It's a PCON.7. PCON register 7th bit is SMOD register. Let us see what is SMOD register. In SMOD register is a name itself. S is serial baud rate. S is a serial baud rate. MOD is modify bit. So baud rate is modifying when serial baud rate is modifying with the help of SMOD bit. So now SMOD bit is a serial baud rate modifying bit, and this bit is it is 0 at reset. It is set 1. Okay, so now this bit is set or reset with the help of program. With the help of program, we can either set or reset the serial baud rate modify bit. Okay. Then GF1 is a general purpose user flag 1. It's a one type of flag, general purpose user flag 1. GF0 is general purpose user flag 0. This is flag 0, flag 1. General purpose user flag 1 and general purpose user flag 0. These two are set or cleared with the help of program. Nothing but with the help of software. We can set or reset these two flags. Then PD is a power down bit. PD is a power down bit. Okay, this bit is also set or reset with the help of software. Okay. Next, ideal. Ideal is another mode. It's called it as ideal mode bit. This is a power down mode bit, ideal mode bit. So here also set or reset with the help of software. So like that, these bits are set or reset with the help of software. And SMOD is very important. It's a serial mode modify baud rate bit. Serial mode modify baud rate bit. Okay, these two are general purpose flags. Flag 1, flag 0, and PD is a power down mode, and other is ideal mode. Two modes. We can select power down mode or ideal mode. And these two are set or reset with the help of software. Like that, serial port registers are mainly two types. One is SCON and other is PCON. Okay, so these two are very essential. Like that, we can understand the serial port control registers of 8051 microcontroller. Thank you for watching this video. If you really like, please kindly share my video and subscribe my channel. Thank you.